So you asked a question about what is calculus really?
Yes.
How does it differ from normal mathematics application? Right?
Yes.
Okay. So I can actually get the answer from you because you know all this stuff, but I'll just do you want to try that for a while? Like 2 minutes with that? What is one thing that calculus attempts to do?
You finding like what was the specific word for this?
Think about how we start discussing about calculus, right?
Finding a point on a curve, something like that.
Finding a point on a curve? You can find a point on a curve anytime.
No, like finding the slope of a curve.
The slope of a curve, yes, but that's what specializes calculus. The slope of a curve. Now here's a curve. I will need this point A to point B, but then let me do a curve around here. Here's a curve. Now where's the slope of this curve? If it was a linear curve, just like that, that means how do you interpret this curve in terms of x and y? What do you say?
I say that for every point in x, the y value changes.
It just changes over here too.
For every value of x, the y value changes equally.
Right, equally at a certain rate. And the slope is just this, right?
Yes.
So this linear curve, no matter where you take the slope, always going to be the same. So we can say the slope of a curve. The equation for this curve is y equals.
You mean line?
A line is a curve.
Yes, I know.
Mx plus b. So this m here is the slope, and this linear curve has the same slope between any 2 points or at a single point as well. But this curve is a polynomial expression, so it might be function of x equals y equals, I don't know, maybe x cubed plus 2x squared plus 3 maybe. Okay, and if I tell you to draw the slope of this curve, where are you going to draw it?
Every point on this curve has a different slope.
Exactly. So there's really no slope of this curve, one single slope. What does it have rather?
Multiple slopes.
And for every x value you put in here, this function here,
yes,
it's going to give you a different point on the curve according to the corresponding y. You change the x, becomes y, right? And at that point, the slopes will be different for different points, right?
Yes.
So what is calculus doing here?
Calculus is finding the slope on a curve for any individual point.
Any point, yes, individual point, a single point. Okay, so it can find a slope in here, it can find a slope in here, it can find a slope in here. Now, how does calculus do that? Like in terms of this equation, so you're given the equation of a curve, and then you're saying that if so you have function of x, or y equals function of x equals x cubed plus 2x squared plus 3, given the equation of a curve, and you are asked, or you claim that if I find the derivative of this function, which in this case is going to be actually 3x squared plus 4x, right? you're claiming that this equation now can actually give you the value of the slope. A slope has a value, remember, a slope has a value in terms of y over x, right? Delta y over delta x. This is the value of a slope, right? Delta y over delta x. So this is the value of a slope. What actually is saying is that if you replace this x, it's going to give you a certain x on the x-axis up here, the x coordinate here on the graph. And at this point, it's going to tell you the value of the slope. The value of the slope being how much angle or something it's forming. It's not giving it in terms of the angle, it's just giving you the value of the slope. Okay, so this is a slightly steep, not really steep, but you know, some kind of steep, but it's positive upwards. But if you look for a slope around here, it's gonna go this way downwards, and it also has a value. So to figure out that value, we just took a derivative of the curve, right?
Yes.
And the derivative gave you a new equation, right? And we know that once you find the derivative of that curve in with respect to the unknown variable itself, right? Now this, every point of x, if you insert it here, is going to give you the value of the slope. From the value of the slope, you can actually also find the angle of the slope, and etc., etc. Okay. Now the question is, why does taking a derivative, or how does taking a derivative actually give you the value of a slope at a certain point? Do you remember that? That is the answer to the question, what is the difference between calculus and a normal mathematics? So do you remember how we figure out? So if you have a curve, let's say like that, okay, do you remember how we actually figure out the slope exactly at this point through calculus? Remember, sorry?
Limit.
Exactly, good point. Limit. So usually this is how we start thinking about slope, just in a very simple and fundamental level, right? You have a straight curve, you take 2 points, always 2 points need to be taken to measure a slope. That's the fundamental. Not in calculus. Calculus, 1 point is enough. But in normal geometry, coordinate geometry, you need one of the x's here. Let's say this is x1, and another x in here. You need x2. And each of these x1 and x2 is going to have a corresponding y1 and a corresponding y2, right?
Yes.
And the way we figure out the slope is the difference of this 2y over the difference of this 2x, which in this case is y2 minus y1, x2 minus x1. Now, the objective or the beauty of calculus is it doesn't need 2 points. And that's why it can do for a single point. And you said the right answer. To get rid of the concept of 2 points, we apply
Limit.
Limit. What is applying limit mean in this case? So let's say, ideally, to find out this slope, which, you know what, could have been, let's say, how do I say this? Okay, this could be a curve by itself, a linear line by itself, right? And if we want to find out the slope for this line, we do 2 points here and here, and then do that. But the question is, we're not doing that. We're just finding out a slope in here, so we don't need 2 points again, right? So what are we doing to make the 2 point to 1 point? We're applying limit, you said, right? What kind of a concept of limit do we apply here? That makes this 2-point squeeze to 1 point.
As the limit approaches 0.
Very good. As the limit approaches 0, now we're going to have to understand that in depth a little bit, right?
Yes.
x2 minus x1. Okay, so as the limit approaches to 0, what do you understand by that?
Not much.
You do. Look at this. Think about this. We're trying to apply a limit of x as x approaches 0 on this. Look at this carefully. Where are we applying the limit to?
We're applying the limit to the 2 points.
So delta x as delta x approaches 0. Right? What does delta x mean?
Delta x means the change in the x variable.
Or it's just, look at this sign. It's just a plain language, simple language, fundamental algebraic language. What does the minus say?
Subtraction.
Difference.
Difference. Okay.
You always think from basic terms. It's going to be very easy. So it says difference. So if we have delta x really is an x2 minus x1, which is a difference. Difference. Now if we say delta x approaches 0, then that means the difference
Approaches 0.
The difference approaches 0. That's correct. If the difference approaches 0, what does it mean? So we have 2 points, x2, x1. Now this difference now, let's say it's 3. If it starts to reduce, it's going to go towards 0, right? Starts to reduce, it's going to be 2, 1, 0.9, 0.8, 0.1, 0.001, and smaller and smaller. What is happening to these 2 points? Right now, the distance between these 2 points is 3, and it's slowly approaching 0, this difference. From 3, it's becoming 2. From 2, it's becoming 1. What is happening to these 2 points? What is happening to their position?
They're coming closer to each other.
They're coming closer. So if the position of the distance of the position becomes so close that it's almost like 0, but not 0, okay, what is this 2 points going to look like?
1 point.
Exactly. That's how limit is applied to make 2 points come to become
1 point.
1 point. And because 2 points are required to form or to calculate a slope, it's still going to calculate a slope, because like I said, 2 points become 1 point. That's true. 2 points becoming 1 point, but it's actually the definition of limit is if it approaches 0, then that means it is not 0, but it is the closest that you can think of 0 and even closer. So it's almost like so close that you cannot actually even think closer, but it's just closer than that. And that will make it almost look like one single point. But remember, in reality, there's actually 2 points still. As long as there's 2 points, you can still do that slope. Now, as the x2 and x1 became closer, so did y2 and y1. So the fraction would still have that equation, which is delta y by delta x. Only thing is that x this time has come so close because we said that delta x is approaching 0, as well as corresponding delta y is also reducing in the same way. So it's still able to give you a slope, although it's like 1 point, and we know that to estimate a slope we need 2 points. In this case, We don't have 2 points, but it is so close that the 2 points are almost like 1 point. So we're basically figuring out a slope on that single point. Now, in normal algebra, you couldn't do that. You couldn't come to a single point. You were not applying limits. Okay? Because you're not applying limits, you cannot find a slope in the single. Why is the single point important? Because time by itself is moving in so much fractionated way that it has a single point, and so on. There are many things like that. We'll go to that example. Now our time is over, so we'll just end it here. Okay.